Hello and welcome to my channel. Today I'm going to show you a easy way to create subprocesses in Deno, and this is an interesting feature. So I have created a program that will execute a Node.js script, and it will create an executable in C++, and then it will run that executable. This is something you might want to do if you want to create routines and processes that are best suited in using other languages than Deno. And I think this is something that you might encounter if you are doing any DevOps or back-end operations. So here is, we have a main TypeScript file, and in this file I have three routines, three functions. The first one is run Node.js process, the other is building the C++ program, and after that running the C++ program, and I'm going to show you what every method is doing. So let's start by running node process. It's actually an async function. It actually creates a variable of type process, Deno process actually. So if you hover over the name of the variable, you see that it is a Deno process that is taken a command property and standard output, standard error streams. If you want to run a subprocess, you actually use the command run from Deno namespace, and that command, run statement has the command array, and inside that command array you place the first must be the name of the binary you want to execute. In this case it is node, and you list any parameters you want that binary to receive. In this case we are going to receive a file called counter.js, and I'm going to show you that file in a bit. And that's it. I'm piping the standard output and the standard error to the parent process, because Deno the subprocesses in Deno inherit the streams from the parent process. What is going to happen next? I'm calling this process node process. After it runs, I'm going to check whether the status of this process is fine or not. And you can see here I'm checking if the code of the subprocess is 0, which means that everything was okay. And I'm going to check the output of that subprocess and whether there is an error or not in the error stream. So in case the code is 0, which means everything was okay, then I'm going to write to the standard out the output that I have received from the standard output of the subprocess. And I'm going just to log a phrase that everything was okay. In case everything, something bad happened, then I'm going to, of course, log out the error message. Okay, and I'm going to show you now what's happening in the counter.js file. This is a very simple script that is only logging time into a file called output text inside a data folder. And it's going to log the time for about 5, 6, 7 times, depending on how the async operation is going to run. So because appending file here in this context is an async operation, so I'm having a callback here in case of an error. If there is an error, then log out the error. If there is no error, then simply log the time into the file and show it to the console. If we exceed 5 times of running this of this function, then we are going to stop and we are going to exit. Other than that, we are increasing the counts by 1, and we are executing the function every second. Okay, so that's it for this counter.js file. There is nothing there. And back to the main.ts function. The second will be building a C++ executable. So if you want to interface with C++, you want to do something with C++, and that could be any other language. It could be Rust, it could be another Node.js script, it could be Python. It doesn't matter. The matter here in this tutorial that I'm going to show you that this is possible to do. So in this build C++ exe method, I'm going to set the current working directory. So first I'm going to check whether the current directory is the standard one, meaning that the parent directory, the parent process Deno, that is running Deno, actually gets the directory that the main function is sitting in. So in case you want to change that working directory, you need to set it explicitly. In that case, I'm not going to do that. I'm just going to ensure that the working directory is the same as the parent process. And here I'm going to run another process. It's called compile process. And the binary is going to be G++, which is the standard compiler for C++. And I'm going to list a set of parameters for that binary. The first of which is the output file where I'm going to place my executable. And it's going to be in the home folder, in the binary folder. And the script that I'm going to build or compile is main C++, which is in the scripts folder. And again, I'm going to say pipe the standard output and standard error to the parent process. So again, I'm checking if the build process is okay, and I'm checking what is the output of that and what is the error stream of that. If the build code is 0, which means everything went okay, then I'm going to write the output stream to the standard stream of the parent process. And I'm going to log just a message that we have finished doing that. Other than that, if there is an error, then I'm saying where that error has happened. And I'm going to decode the error message, and I'm going to log that to the error stream. So then after that, I'm going to run that executable, that C++ executable that I have created. And now that executable is going to be in the binary folder in the home directory, which is 3 levels up. So if you go 1 level, 2nd level, 3rd level, and you should be here in the home directory, and you enter a binary directory, and there is the, as you can see here, the binary, the executable that I'm going to run, but it's not there yet. So this directory is at this moment empty. So that's it. Of course, these 3 methods are async because there are many async operations inside them. So I'm going to create them as async, and I'm going to await them until they finish. Yeah, and that's it. So let's run the function. Let's run the Deno process and see what's going to happen. So it's Deno. Actually, first run, allow run, and we are going to run the main function. Watch the output file, because I'm going to output the time from the Node.js process. So I'm going to execute. As you can see, we are logging the time here. and after that finished logging the time. We executed 7 times because of the async nature of the methods that we are using. So it's not exactly 5 times. It's when we exceed 5 times of running logging the time process, then it will stop. So after that, you see we have finished the Node.js process, and then we executed the C++ building process, and we have finished that. And after that, we executed the C++ function, which is actually doing nothing. It's not the point to understand the C++ code, but here in this example, we are just counting 10 times, and we are logging the counter to the output, to standard out. So if I run the counter executable myself, so you see we are counting 10 times. So, and as you see, there is the counter executable that wasn't there before. So here you can see that you can run pretty complex routines and subprocesses depending on your needs, right from inside the Deno, which is a very, very interesting feature to use, especially if you are doing a lot of DevOps operations. So I think that's it for this tutorial. I hope you have enjoyed that. If you liked what you have seen, please like, share, and subscribe, and see you in the next time.